How digital signatures work. Imagine sending an important document across the internet. It might be a contract, a financial record, or a piece of software. The person receiving it needs to know two things. First, that the document really came from you. Second, that it has not been altered along the way. In the physical world, you might sign the paper with a pen. But in the digital world, things work a little differently. Instead of ink on paper, computers rely on something called a digital signature. Digital signatures use cryptography to prove who sent a message and confirm that the contents have not been changed. So today we are going to walk through how digital signatures actually work and why they are such an important part of modern internet security. Chapter 1. What a digital signature is. Digital signature is a cryptographic technique used to verify the authenticity and integrity of digital data. Authenticity means confirming who sent the message. Integrity means confirming that the message has not been altered. Digital signatures accomplish both goals using a combination of mathematical algorithms and encryption techniques. Unlike a handwritten signature, a digital signature is generated through calculations rather than handwriting. Yet it can still provide strong evidence that a specific person or system created the message. Chapter 2. Public key cryptography. Digital signatures rely on a concept called public key cryptography. In this system, each user has two related cryptographic keys. One key is called the private key. The other is called the public key. The private key is kept secret and known only to the owner. The public key can be shared openly with others. These two keys are mathematically connected so that data processed with one key can be verified using the other. This relationship allows digital signatures to work securely. Chapter 3. Creating a digital signature. When someone wants to digitally sign a document, the process begins with a mathematical summary of the document called a hash. A hash function takes the document and converts it into a short string of numbers and letters. Even a small change in the document will produce a completely different hash value. Once the hash is created, the sender encrypts that hash using their private key. The encrypted hash becomes the digital signature. The original document and the digital signature are then sent together. Chapter 4. Verifying the signature. When the recipient receives the document, they perform a verification process. First, they calculate the hash of the received document themselves. Next, they use the sender's public key to decrypt the digital signature. This reveals the original hash that the sender created. If the two hash values match, two important conclusions can be made. The document has not been altered, and the signature must have been created by someone who possesses the private key associated with the public key. Chapter 5. Why hash functions matter. Hash functions play an important role in digital signatures. Instead of encrypting an entire document, which could be large and slow to process, the system signs the hash of the document instead. This makes the process faster while still maintaining security. Because hash functions are extremely sensitive to changes, even a single modified character will produce a completely different hash value. This allows the verification process to detect any alteration to the document. Chapter 6. Certificates and trust. In many situations, the recipient must also verify that the public key truly belongs to the claimed sender. This is where digital certificates come into play. A digital certificate is issued by a trusted organization known as a certificate authority. The certificate links a public key to a specific identity, such as a person or organization. By verifying the certificate, the recipient gains confidence that the public key belongs to the correct source. Chapter 7. Digital signatures in everyday technology. Digital signatures appear in many everyday technologies. Secure email systems may use digital signatures to verify the sender of a message. Software developers sign applications to prove that the software came from an official source. Websites use digital certificates to establish secure connections with browsers. In all of these cases, digital signatures help ensure that data has not been tampered with during transmission. Chapter 8. Preventing forgery. One advantage of digital signatures is that they are extremely difficult to forge. Because the signature is created using a private key, only the key's owner can generate a valid signature. Even if someone has access to the public key, they cannot create the same signature without the private key. This property provides strong protection against impersonation and tampering. Chapter 9. The role in modern security. Digital signatures have become a fundamental component of modern cybersecurity. They help secure software updates, protect financial transactions, and verify the authenticity of communications. Without digital signatures, it would be much harder to trust that information transmitted across the internet is genuine. By combining encryption, hashing, and trusted certificates, digital signatures create a reliable method for verifying digital data. To wrap up, digital signatures use cryptography to confirm both the identity of the sender and the integrity of digital information. They rely on public key cryptography, where a private key creates the signature and a public key verifies it. A hash of the document ensures that even the smallest change can be detected. Certificates help establish trust by linking public keys to verified identities. Together, these technologies allow digital documents and communications to be authenticated securely across the internet. This has been a mini Leviathan production. If you enjoyed it, check out our other videos. Comment below what other topics you would like us to cover. See you in the next one.